Let's try another one of these problems. So let's start by drawing our first vector, and I'm going to do the 2 first. We'll put our x, which is also our adjacent, because our theta is right there, and our y, which is also our opposite. Now we know that this theta is not 200 degrees, because you cannot have an angle in a right triangle more than 90. So if we put our unit circle on here, and I'm going ahead and putting the positive and negative signs to help us, we know that this is 200. But if we see our triangle here, we want to know this angle. Well, if this is 180 and this is 200, then our theta has to be 20, because it's 20 more than 180. So we can solve for our x using cosine. Cosine of 20 equals adjacent over hypotenuse. So our x is equal to 1.9. And if we look at the direction, it's pointing towards 180, which makes it negative 1.9 at 180 degrees. And honestly, this negative sign and this 180 are redundant. They tell you the same thing. But I like to have both of them out of habit and making sure that we see what's happening. Now, to find our y, the sine of 20 degrees equals opposite over hypotenuse. So our y is 0.68, and because it's pointing at 270, it's going to be negative 0.68 at 270 degrees. So we have these for our first vector. Let's look at our second one. We have 4. This is our x. Because that's our theta, x is also equal to adjacent. We have our y, which is also our opposite. Now we have to talk about what that theta is. We know from here to here is 330. But we want to know this angle. If this is 330 and this is 360, this part has to be 30 degrees. So to find our x, we're going to do cosine again. Cosine 30 equals adjacent over hypotenuse. So our x equals 3.5. And because it's pointing at 0, it's positive. So positive 3.5 at 0 degrees. To find our y, we do the sine of theta equals opposite over hypotenuse. And we get 2, and because it's pointing down at 270, we get negative 2 at 270 degrees. So now we'll sum them. And I like to label it sum or resultant or something so that when I'm referencing the work later, it's easy to find where I summed them. Please reference it somehow because you've got lots of x's and lots of y's up here. So for x, I've got negative 1.7 plus positive 3.5 equals positive 1.8. And because it's positive, we know it's at 0 degrees. And for our y, we have negative 0.68 plus negative 2, giving us negative 2.68. Because it's negative, we know that that's at 270 degrees. So that's our x and y sum. Now we can draw this, and we're going to draw our x first. And because it's at 0, we'll draw it pointing that way. And our y is at 270, so we'll draw it pointing down. And our resultant is right here. And our theta is right here. So to get our magnitude, we use the Pythagorean theorem. 1.8 squared plus 2.68 squared is our resultant squared. So our C is equal to 3.2. And it's larger than our x and our y, so that makes sense. Now to find theta, we use tangent. Tangent of theta equals opposite over adjacent. We get 56 degrees. And we have one more step because we need to put this value into unit circle. So if we draw a unit circle on here, we have 0 and 360, 90, 180, and 270. Well, we want to know this. We know that this theta is 56 degrees. We know that this is 360. So if we do 360 minus 56, we get that our answer, this angle all the way around, is 340 degrees. So our final answer is 3.2 at 304 degrees.